Done. We have completed this till this part, right? Define function. Okay, Daniel. Hello. Yeah, we have completed this part yesterday. So so let, let's move for further. So basically, this is database design concept. It's so under that we have a normalization. So it's a remove redundancy. Okay, normal form meaning 1F, no repeating column. Okay, normal form meaning so 1F, NF, no repeating column. We should have no repeating column. 2NF, no partial dependency. 3NF, no transitive dependency. So again, 1NF, first normal form. What is this? No repeating column, first rule. Each field contain atomic, it means single value. Okay. So under the one NF rule, we have two things: no repeating column, and each field contains single value. See, if I write email employee ID 1, name Amit, and skill SQL and Python in one column, so this is bad design. According to this, no repeating column and each field contains single value. So here two value. That's why this is a bad design. We should not design our table in database like that. Okay. So problem, multiple value in one column. Then how to design? Convert one NF, one column for employee ID, one column, and skill divided into two parts, one row for SQL and one row for Python. So this is correct design, not like this. So this is called one NF. Okay, under that we have no repeating column and each will contain single value like this. Then 2NF, second form, normal form. So must be N1F. So must we follow these two rules, single column and one single value. So first is must follow N1NF rule, and then no partial dependency. It means no key column should depend on full primary key. Okay. According to this, non-key column should depend on full primary key. So example, not in 2NF, employee ID, course ID, employee name, course name. So composite key is employee ID and course ID. Okay. Problem, employee name depend upon employee ID, course name depend upon course ID. Okay. So this is bad design. We should not design like that, but we have to design like this. Convert to 2NF, that is employee table 1. So employee ID and employee name, and again table 2, not in a one table. We should not we should not create in a single table. We have to create two tables, one for employee, that is the employee ID and the employee name, and second for course, that is course ID and course name. Okay, not like this. So this is the 2NF rule. Okay, and again third column, if there is an enrollment, so employee ID and the course ID, that is called enrollment. So this way we have to create a table, not we have to getting all the details in a single table. Okay, no partial dependency. Then 3NF, third normal form, so must be in 2NF. It means first of all it should be follow N2F rule, and N2F rule must follow the NF1 rule. So if you talk about 3NF rule, so employee ID, department ID and department name. Problem, department name depend upon department ID and department ID depend upon employee ID. Okay, so indirect dependency, that is called transitive. So this is also a bad design. We should not create a table like this. Okay, instead we can convert to 3NF, that is employee table, a separate employee table, that is employee ID and department ID. Then department table, that is department ID and department name. No direct dependency. Fine. So each are separate table. So this is called 3NF rule. We should create a table like this, not like that. So these three rules we have to follow under this database design concepts. Okay, that is called normalization. Now primary key. So what is primary key? Employee ID in primary key. So it's a unique key for each row. For each row, employee ID is unique. It should not be repeated. That is called primary key. Foreign key. Deleted row. Okay. Delete from employee where employee ID is 8. Okay. Delete column. That is alter table. Okay. So delete from employee. Let me activate the database first. Use company DB. Okay. Now if I check, select star from employees. Okay. So these are the our table: employee ID, employee name, email ID, salary, phone, department ID, manager ID. Now, so here delete from employee where employee ID is 8. So there is no employee ID 8. Okay. Alter table employee, drop column department ID. So department ID is this one. I will going to drop. So this column will be deleted. Then add column department ID, alter table employee, add column department int, update. So it's already there, but it should be created in a new manner. So department ID 1, department ID 2, department ID 3, where employee ID 1526 like that. Okay, let me drop this one first. Alter table employee, drop column department ID. So this is department ID. Let me drop this. Okay, drop. No department ID. Now add column department ID, alter table employee, add column department ID, then update employee, set department ID 1 where employee ID is 1 and 5. 1 and 5 should be department ID 1, and for 2 department ID is 2 and 6. Okay, and then for 3 department employee ID is 3 and 4. Fine. So let's create it. Alter table employee, add column department int. So it will add a column. Fine. A department column, department ID column created. Let's check it. Fine. So it's created but null. Now I have to add this one. Update set department ID where employee ID is 1 and 5. Like that it will set. Hold on. Done. Created. Now check this. Yes. 1 2 3 3 1 2 like that. So it's distributed department ID for according to the employee ID here. Now add foreign key constraint. So alter table employee, add constant FK department, foreign key, department ID, and reference department under department. So we have one more table, that is select star from department. Department. What is the name of column? That is department is fine. I think spelling mistakes. Departments. S. Now done. So I'm going to run both the things again. Okay, so one is employee column table and second is department table. Now I'm going to use this department ID as a foreign key because department ID is common between these two tables, employee table and the department table. So in department ID is here and department ID is here. Now, so alter table employee, add constraint fk depart foreign key department ID and reference departments department ID. Okay, this way we are going to add foreign key constraint. Let's do it. Alter employee, add constraint fk department, add some error, fail to add foreign key constraint, missing index. Okay, insert into employee ID, name, email, salary, depart, value, invalid. Okay, okay, create index. Hold on, man. Some error is throwing. Let me copy this. So alter table employee, add constant fk. Fail to add foreign key constant, missing index for constant. Okay. Okay. Hold on. Let's solve this issue because we have to know how to solve the issue whenever we face while we are running the code in real life. So we have to understand how to solve this kind of problem. Copy this. Okay. Paste here. Again copy this. Copy. So it's saying why this happen when you create foreign key. MySQL required that reference column department or department ID must be a primary key or a unique index at list index. Okay, right now your department or department ID column does not have any index. MySQL block the constraint. So what to do? Okay, describe department, alter table department, add primary key department ID. It's already there. Add index only. Okay, let me create this index. Done, created. Now run this code. Created. Okay, so after creating an index, we are creating a foreign key constant. Okay, now if I try to add a new row into this one employee table, it will not allow. So we have till 6 row. If I want to add 7th row, insert employee department ID, employee name, like that, it will not allow us. So employee ID, employee name, let me check. Employee ID, employee name, email, salary, phone. There is no phone, so let me create a phone. After salary, phone, phone, comma, department, departments, department only. Okay. Then manager ID, or maybe I'm going to drop these two, department as well as manager ID. I'm going to drop these two columns. Phone is okay. Phone is okay. Department and manager ID I'm going to drop. Auto table employee drop column. This column I'm going to delete. Which column? Department. Department. Gone. One more column I want to delete. Manager ID. I'm going to delete manager ID also. Manager ID. Done. Now according to our this insert employee ID name, email, salary, phone, and department ID. Okay, I want to insert this value. So see, this will not allow because we added a constraint of foreign key. So currently we have a foreign key, this one. If I change this to 10, it will accept it because foreign key 2 is here. So here I am using 2. So it will accept it, but if I use 10, it will not accept it because there is no 2 to 10 as a ID. Okay, so this will accept it first. Insert into employee department and department value 7, column count does not match value count at the row. 1 1 2 oh, okay. So after email ID we have salary and then phone number. We have to add phone number 998865 something like that, comma. Now try. Okay, so this time it's added. see, seventh row added. Okay, but if I change this to as a 10, so there is no 10 as a department ID, and we have created a constraint with this foreign key here. Constraint with this foreign key as a department ID. If we use different department ID other than this constraint, it will not allowed. So I am using 10. 10 is not there. So let's try to create. Even change this, make this 8. Change the name. New one employee and other thing are same. Insert into employee and this one something like that. So cannot add or update child row, a foreign key constraint, because we created a foreign key constraint here. It doesn't allow foreign key constraint because we have created a constraint with the foreign key. Okay, see, other than this foreign key, if I use, it will not allow to insert. So that is called add foreign key constraint. After that we have indexing. Okay, so create indexing, create index IDX salary on employee salary. So speed up the select query. Okay, speed up the select query. This create an index on an employee table. It helps MySQL find row faster, but it does not store data separately like a table. Okay, so first create it. Create an index. Create index and name of the index is IDX underscore salary on employee and salary column. Okay, so it's create an index. So index is created. Now select star from employee where salary is greater than 50. Select a star from employee where salary is greater than 50,000. Yes, these are the people whose salary is greater than 50,000. Now, how to check if index is used? See, explain, select star from employee where salary is greater than 5. So it will explain you how the index is using, because we created an index. So if I write like this, it is using index, not directly using the table. So explain the select things here. So ID, simple, select type, then table, index. See, this is the index IDX underscore salary because we created a this index. So when I write select from employee where salary is, it's using index, not getting all the table. Okay, that's why it's very fast. Now how to view the index? So index from the employee. So index from the employee. It will show you the index. See, primary key, FK, department, IDX. So key name, these are the key names. Okay, so we created index like this. Now delete the index. How to delete the index? Alter table employee, drop index and name of the index. So it will delete the index. Whatever the index we created, it will delete it. Index deleted. Now if I run this code, show the index. No, this index IDX underscore salary. Only two index. Okay. Now transaction and the logs. Transaction example, start transaction, update employee, set salary equal to salary plus 5,000 where employee ID is 1. If correct, commit. If error, rollback. So it's same like Python. In Python we learn about the rollback and commit. Same way, if this is correct, it will give you the answer, otherwise rollback. It doesn't throw the error, it will roll back. Let's try this. Start transaction, update employee, add salary in employee 1. Okay, currently what is the salary of employee 1? Let me try this. Select from star from employee. So employee ID1 has the salary 60,000. Now I'm going to add 5,000. It's rollback. It's not happen. Uh, Commit first, commit affected, and then rollback. Let me check this now. Wait, let's check. Okay, it's added 5,000 in the employee ID, this one. Okay, if I make this something wrong, let's suppose this time I'm going to get, so if I'm going to do something wrong, let's suppose we don't have employee ID 10, I'm using 10. So when I run this, it will not add 5,000, but it doesn't throw the error, it say rollback. See, rollback. There is no 10th row in our table, but it doesn't show anything wrong, it say rollback. Okay, see, when I select from start from employee, just right here. There is no 10th row, but it doesn't show any error, it's say rollback. Okay, that is the use of transaction and lock. Now query optimization, use explain select from employee where salary is greater than 5,000. See, let's explain this. Simple ID is one, select type, table, partial, all. So this way it can explain query optimization, use explain. It's so index uses query cost scan type. Okay. So this is all about the module 4, and we have completed MySQL. Okay, and we have done so many things. Yes, Daniel. So we have completed the module 4 also, and you need to have a practice a lot. Okay. Uh, yeah, I will share the file as well as the video also on the group. And tomorrow we can start Tableau. What's your opinion? And Sally, would you like to start today? Tomorrow, no? So I'm going to stop the class because we have completed MySQL. We can start Tableau tomorrow. Done? And okay, Wednesday, Thursday, Friday. Try to finish within this week. Okay. And which part is left for you, man? Daniel, you have read Python. How many courses you have completed? Python, MySQL, and Tableau we will complete in 3 days, 3 or 4 days. Okay. Then you have left Advanced Excel and Power BI is left. Advanced Excel and Power BI is left for you, right? So we will cover. We will cover. Let's finish whatever we are finishing in a flow. Let's go. Let's complete it. And I will take the class, yeah, separately for you, the Advanced Excel and the Power BI. Okay. So good night then. Meet tomorrow. Start with the Tableau. Then okay. Bye bye. Good night.